everyone, my name is Eric Santos, General Manager of ESI Flange Rentals. Today I want to do a brief training on how to use our tools properly in the field, which have been incorporated in today's industry's best practices. However, before we get started, I want to touch on some of the traditional methods that are still being used in today's industry. You know, every time I go over this slide, I hear chuckling in the background or somebody say, "I've seen that before." And that's because this scene is all too common in today's industry. If I asked one of you to describe what you see, I'm certain your answer wouldn't be positive. Just from a quick glance, there are tools scattered everywhere, assuming that you guys can't find the right tool to get the job done. All of which is not only risky, it's also very time consuming. And I'm sure labor intensive as well. All of which negatively impacts your bottom line. As DSI heard stories such as this or accidents resulting from bad tooling, we set on a mission to connect field workers and our customers with tools and technology that will help make their lives and their jobs safer and more efficient. Today, we're going to discuss how our tools are going to help accomplish that goal. We're going to do that by showing you some of the tooling options available for you and your team, in addition to how to pick the right tool that best fits your application. Then we're going to show you how to operate that tool and to position it correctly on a pipe to avoid any type of tool failures or accidents that happen from tool failures. And then we're going to talk about the specific applications our tools are designed to fix and the procedures to do so and overcome those challenges you're experiencing in the field. ESI has served the industry since 2009. Over the years, we've heard our fair share of good stories and bad stories, which is why we made it our mission to improve the lives of our customers by connecting them with superior tools and technology designed to fit any budget, so we can finally put those inefficient processes as a way of the past. So some of the traditional methods came to be simply because this type of technology didn't exist. So what you had were craftsmen, field workers adapting rigging tools designed for similar applications with the task of manipulating and controlling pipe. Unfortunately, these type of tools became the norm. It became what people were comfortable with. However, now that technology is improving and companies are focusing more on safety and building a safety culture, the tooling we discussed today is becoming the standard in today's industry. Which is why, in addition to training you on how to line and move flanges in a much more controlled and precise manner, we're also going to discuss procedures to preemptively avoid some of the hazardous conditions you saw on a previous slide. This course is based on 3 critical points: safety, speed on task, and joint integrity. So let's go over the tooling options available for your team that incorporate all 3 critical points. So we have several options available to you to come in both hydraulic and mechanical that vary in strength and size, that cover most standard and non-standard flanges. See, when you see the term 3-ton, this is referring to the amount of force that it applies, the amount of lining force that it applies to the flange. So we have a 3-ton tool that's made for small to medium size, low pressure flanges, a 4-ton tool that's made for medium sized flanges or even large flanges with low pressure. And then our 9-ton tool is a hydraulic model. It's made for high pressure, large flanges. When choosing the right tool, you must first understand your application. So you'll need to identify 3 characteristics for all the flanges you'll be working on. That includes type of flange, MPS size, and pressure class. Once you've done so, you can either bring it to an ESI staff member, or we'll provide you a chart so you can identify the right tool for your application. So once you've gathered that information, you can now match it up to the appropriate tool that's going to best fit your application. With that being said, let's go over the mechanical tool specifications and requirements. The 3-ton tool requires at least a minimum bolt hole clearance of 0.95 an inch, so just under 1 inch. It's made for small to medium-sized flanges and can produce just over 3 tons of force, of aligning force, at 50 foot-pounds of torque. It can handle both rotational and lateral misalignments. The 4-ton mechanical tool is very similar. However, it produces 4 tons of force at 50 foot-pounds of torque and is appropriate more for medium-sized or even large flanges, low pressure. It needs a bolt hole clearance similar to the 3-ton tool of 0.95 inch of a bolt hole, and it can handle both rotational and center, otherwise known as lateral misalignments. So now, if you've identified the mechanical tool as a tool that best fits your application, you're going to want to learn how to use it and how it works. Please be advised that this slide actually comes into the instruction manual, which comes with your tool. So I don't want to focus on it too much, but I do want to touch on 2 important features. First is the hook. The hook is what I believe is the most important part of this tool. When we talk about 3-ton, 4-ton, 9-ton tool, the hook is what makes that possible. It's what carries the load. So it's very important that hook is placed completely inside of the bolt hole rather than on or halfway on or halfway off. The next feature is the wing. The wing can slide out back and forward, allowing the operator to work on multiple applications. Some joints have larger gaps, some have smaller. The wing allows you to extend as you need it to. In addition to that, being able to slide backward and forward allows the operator to leave it on so it doesn't fall out of alignment during the bolting process. So let me show you a video now on how the tool works, which will give you a visual on what we've already talked about today. So now let's go over our hydraulic model's specification and requirements. We have 2 options. Both options have the capability of providing 9 tons of aligning force. They also require an inch and just under an inch and a quarter bolt hole clearance to work properly, and both have the capability of providing 9 tons of aligning force at 10,000 psi. They handle rotational and lateral misalignments and come with their kits, so they come with a closed circuit hydraulic pump, and that means the operator can hold that pump in any angle without the fear of airlocks or leaks. In addition to that, the pump has a gauge, so you know exactly how much force you're applying to that flange. So the whole model of this is safety and control and precision. So if you've identified the hydraulic model as an appropriate model for your tool, then again, you're going to want to understand how it works and how to use it properly in the field. Please be advised, similar to the mechanical model, this slide is in your instruction manual that's going to come with the tool. So I don't want to go over this in too much detail, especially since they work in very similar fashions, with the exception of the hydraulic cylinder. The only thing I want to say is, most of you guys already know this, is ensure that your connections are all fastened properly and tightly and there's no thread showing or whatnot. It has the wing and the hook, which we've already covered the importance of those features. So now let me show you a video on how the hydraulic model works, which will encapsulate what we've already discussed today. Welcome back, everyone, and I hope everyone enjoyed that video. I also hope that it not only supported what we've already discussed, but it gave you an even clearer understanding on how the tool will work. So now we're going to go ahead and move forward to tool positioning and basically setting up your tool properly on a pipe. Okay, so a lot of this information we've already discussed. However, this will give you a visual on exactly where the hook is located, how it's placed, and how the wing and hook work together to align a flange. And you can see in the transparent picture, the hook is placed completely inside of the bolt hole. The wing is extended out and mated on the opposite flange. Now, the design of the tool is so that the wing actually pushes the flange in the opposite direction, and all of the load bears on the actual hook. So by doing so, it's very important that when you're setting the alignment tool up, that you keep the tool level. This will help ensure that all of the load is completely on that hook and you don't have any issues with tool failures that could result in accidents or whatnot. Now, whether you're using the hydraulic or the mechanical tool, whatever one best fits your application, the operator is going to notice that he has complete control and is able to align flanges in a much more precise and accurate manner. Okay, so what we've learned so far is how to pick the proper tool based on our application, how the hydraulic and mechanical model works, and we've seen videos to support that, and how to set the tool up properly on a pipe to avoid any type of tool failure. So now we're ready to move into the type of applications and those procedures your guys will need to fix those issues they're having in the field. Okay, so our tool is made to correct two types of misalignments. They are lateral and rotational. Lateral misalignments can occur at any point around the flange joint circumference. A rotational misalignment is when the axis of the flanges align but the bolt holes do not. And this can occasionally happen either from poor manufacturing or other forces acting on the flange joint, such as overhang weight or pipe configuration. So let's take a look at how to fix a lateral misalignment. You must first locate the 2 points of greatest misalignments. They will be 180 degrees from each other. Then you're going to select the most comfortable or convenient point to where you can set up your tool. And essentially what this means is the easiest place where you can set your tool up properly. Then at that point, you are going to actuate the tool, whether mechanically, hydraulically, and push the two faces into alignment. All the bolt holes now will be aligned, and you can insert the bolts without any type of resistance. Here's another unique feature about our alignment tool. The wing feature is designed to slide with the spreading or closing of the joint under full load. Therefore, the tool can be kept on the joint from breakout until the bolting procedure is underway to prevent the joint from falling out of alignment again. So now let's take a look at the procedures to fix a rotational misalignment. Step 1 is to locate a bolt hole where you can set up your tool properly. So essentially what that means is a hook can be completely inserted in the bolt hole and the tool is level. Next, you're going to actuate the tool, which is going to cause the flange faces to move in opposite directions, bringing at least one of the bolt holes into alignment. At that point, you're going to insert the bolt inside of that bolt hole completely, and then reposition your tool. And at this point, it's essentially a lateral misalignment. You're going to look for the 2 points of greatest misalignment and set up your tool properly in whichever one's more convenient. Next, you're going to actuate the tool, which is going to result into more bolt holes coming into alignment, and you're going to insert the bolts as needed. On very large flanges, you may have to do this more than once. Okay, so let's recap what we learned today. First, we learned how to pick a tool based on our application. Then we learned how it works, both the hydraulic and the mechanical tool, and how to operate them properly. We also learned how to position the tool properly on a pipe to avoid accidents resulting from tool failure. We also learned the procedures to fix the 2 misalignments, both lateral and rotational, these tools were designed for. At ESI, we look to connect both field workers and tools like technology so that you can do your job safely but efficiently. Because smarter is always better than harder. Thank you very much.